Right. This is actually my fourth time I'm on Wroclaw, and this is the first time I'm on this side of the room. And I gotta tell you, this room looks much bigger from here. Uh, I had to kind of rename my talk because it used to be called Transcoding in Ruby, a story, and people were asking me if I'm going to do the actual transcoding in Ruby. No, I'm not crazy. I am going to use FFmpeg, and I actually had to Google the pronunciation of that because I kept saying it wrong for the past few years. Yeah, you can actually follow the slides live on your phone or laptop. You can either scan the QR code, there is an URL, and in a few minutes the link will also be on Twitter. If you use your phone to check the slides, please put it on full screen and keep in mind that it has to be in landscape, otherwise everything will look broken and you will claim that it's my fault. Right, so I will be avoiding talking about any business side of the project, so please don't ask me about it. The reason is that I really didn't ask for permission to talk about this project, and I'm not really sure what the legal status right now is. I will be also a bit vague about the time frame, just so you cannot so easily Google it. The entire presentation is actually based on the conversation logs that I had and not on the actual code because I no longer have access to that code. So keep in mind that the code examples may or may not be broken or maybe not up to date. So there was once a project. The project was a media platform. Users could upload both video and the audio, and it had an HTML5 video player, so we had to process and transcode the videos. We also had some extra processing because of the secret business sauce that I cannot talk about. So for the proof of concept version, we decided to run on a dedicated server instead of in the cloud. At the time, the solution to do file uploads was Carrier Wave, so we obviously went with Carrier Wave. And since we were Rails developers, we just decided to slap some off-the-shelf gems. So we used Carrier Wave Video for processing and Carrier Wave Backgrounder for doing it in the background, because as somebody here already mentioned, we cannot really transcode videos while they're uploading. You can already kind of guess from the previous presentations how the code actually looked like. It looked more or less like, I think I'm gonna use this instead. The internet is not that reliable. Oh, it doesn't work, sorry. Yeah, so the code looked kind of like this. I'm gonna switch the slides on my laptop because this is a replacement phone and it just died. Great, seriously, I really needed that right now. So the lesson number one is that hindsight 2020, it's always easy to look at something you did years ago and be like, oh my God, how could you let this happen? That should be obvious that the code is gonna be spaghetti and everything. But usually like the knowledge and the experience at the time when you are building something, and you only learn it after a while. So don't judge other people or yourself too harshly. Right, this is not a speaker view. So so how it was built, we had our class video, which is obviously an active record, right? And since it's used Carrier Wave, it mounted an uploader, which was then using the Carrier Wave backgrounder to spawn a background process. And because we are Rails developers, we had some custom callbacks, right? And they were setting some states before the processing. Then we did the actual processing using the Carrier Wave video, which uses FFmpeg. And then we had some other extra callbacks to set the state afterwards. So the lesson here is call back all the things. No, please don't do it. You should always try to avoid callbacks whenever possible. I think this is obvious to people who are coming to this conference often. You already know that, but callbacks make your code really hard to reason about, and it's harder to isolate. It slowly turns everything into a kind of codependent mess. Sorry. Seriously, I spent so much time preparing for this, and I have technical problems all the time. All right, so since we kind of had transcode to different versions, like MP4s and WebM. You obviously used carrier wave versions, and after a while, we also decided that probably we should like change the resolution of the video, create some quality versions, and everything. So a quality picker would be nice. So, oh, sorry, seriously. So we sprinkle a bit of custom DSL on top of that, but that custom DSL actually only hid the ugliness and complexity of the code, so it got a bit unwieldy after a while. So the lessons here is you should probably avoid using carrier wave versions, or at least don't use them for anything even remotely more complex. They're probably good for like resizing a thumbnail or something, but anything bigger than that, it's not gonna end up great. I don't know what the current status is because the project was done a few years ago, but when we did it, there was also a bug in carrier wave that I never really managed to fix, which made it impossible to reprocess only one version of the file. So every time the transcoding broke, and trust me, it breaks often, we had to reprocess everything, which took forever. We also had the problem because when you're building, when you're changing the resolutions of the video, when you're creating the quality versions, and you have the initial original file, then it usually makes sense to transcode from to match the codecs when you are doing this. So for example, to change the resolution from one MP4 to other MP4, if you're always transcoding from this one base file, it's gonna take forever. And carrier wave doesn't really support doing that. It doesn't support creating versions based on versions. So it was kind of choking on what we were doing. It was super slow, so we decided to rewrite the whole thing. So we decided to use one database model per one file. So we still had our video, which was kind of a placeholder for everything, and it had multiple versions, and those versions had different kinds, where the null kind was the original file. We probably could have named it differently, it doesn't matter. And we also needed that special extra processed sauce, business sauce, so we had another set of version that also had a special flag, because the quality versions were the same, but it's just depending on the situation, we were either pushing one of the other version of that, and we still use carrier wave video for that. But remember this part, right? How carrier wave works. You mount an uploader, it spawns some background process and everything. So the problem is that once we moved to many models, we still needed the processing status at the very beginning. Then each version actually had to mount the uploader, spawn the worker, then process the video, then set the state on itself. So we had multiple versions of that, and you can already guess where this is going. And then after each of those processing, we had to check if the other processes were done, so we could set the status as ready. And it caused a lot of problems. It caused a lot of racing conditions because sometimes they finished almost at the same time. So very common issue was that we ended up in a permanent processing stage where it was finished, but the flag wasn't set properly. And this is not exactly what we are aiming for. So we are also getting out of the MVP phase around that time, and we knew that using dedicated server is not going to scale very well. We had a 6 terabyte hard drive there, which was in a RAID, so in case one of them crashed, we didn't lose the files. But keeping it on a dedicated server was super annoying because we were running out of space. We had to do backups manually. It didn't scale very well in terms of processing speed, so we decided to actually rewrite the whole thing from scratch. And it also helped us solve some of the long-standing issues, like being able to just reprocess that one broken version, or restart the processing if it failed and be able to just reprocess the broken stuff, or have a better visibility and monitoring into what was happening without adding even more callbacks. We still have our original video, which is then uploaded. It is stored locally on the same server that still has that 6 terabyte. It then spawned a processing worker, which was checking for the existing versions and was checking if their statuses are correct. It created any missing ones. Then started processing based on priority, because when you are processing video for the use and you want the user to have access to it as soon as possible. This is how YouTube does it. They first transcode the lowest quality version because it's fastest, and only then later they process everything else in the background. And the processing still use Streamia FFmpeg to pass custom arguments to FFmpeg based on the format, based on the any extra things that we needed. And it was also possible to do the processing based on the other versions. So we could first process and transcode the MP4s, and then we could create our special version out of them, which is much faster than working with the original file. And at the end, it uploaded everything to S3. We were using Sidekick, so the uploads were running on a different queue. So we could limit the processing queue so it didn't oversaturate the CPU. And then we could have a different queue for the uploads, which could saturate the network. So the lesson number 4 is that the simplest solution can often be the best solutions. We would avoid a lot of pain if we didn't try to do everything the Rails way with the callbacks and everything, if we didn't just slap all the gems, if we just wrote a simple processing worker that just did everything from the top to bottom. Well, you live and learn. And I got some questions before, so I'm already going to answer them. Why didn't we use, for example, AWS Lambda? The problem with AWS Lambda is that it has a 50-minute maximum execution time, which is probably enough for a lot of cases, but in case of transcoding and processing videos, some of the videos incoming that we had were over 2 hours long, so 15 minutes is not going to cut it. Why didn't we use Zencoder or Amazon Elastic Transcoder? Why did we spend so much time building that? The reason is that all of those things are super expensive. They're great if you are processing maybe 1-2 videos a week or something like that, but we are trying to build a proper media platform, right? And this would ruin us in terms of costs. And we didn't use Docker. Everything was running just on or any containers or anything. It was just running on the bare servers because it wasn't really that popular at the time, and it wasn't really even supported in production, I think. So we transcoded a lot of stuff. The incoming formats were in different codecs, but we mostly transcoded them to MP4s. The reason is that at some point, you had to always have 2 versions of video. You needed to have MP4 and WebM. But then the browser support started to catch up, and at some point, the only people who couldn't watch MP4s were just Linux users that were hell-bent on not having any non-free codecs, and they weren't exactly our business target, you know? We've decided to just focus on the MP4s because it was just twice as fast, because we only needed one version, well, multiple versions, but of only one format. So let's talk about MP4s. MP4, MPG4 Part 14 is a format that is based on the previous format. It extends the ISO base media format, which is, on the other hand, based on the QuickTime from Apple. It's a container format. It's not really this is not the video or audio codec. It contains the information and the codecs inside it. It's made of 3 elements. You have the F-type, which is the file identification, brand names, brand identification. You have the MDAT, which is the media data and streams. And you have the most important part, which is the metadata. And the metadata has all the information where everything is, what it is, and how to find it for the player to know how to play the video. I'm going to give you some tips on transcoding videos in case you ever need to build something on your own. And the tip number 1 is that you should always try to copy streams as much as possible. For example, if you are transcoding different sizes of video, but you keep the same audio track, it makes more sense to just copy the stream of the audio and match the codecs as much as possible because it's just faster. It kind of seems obvious in the hindsight, but it took us a while to get to that point. I mentioned the metadata. It's made of something called atoms, and atoms are more or less fall into 2 categories. One of them is the fixed parameters of the file, and the other are the specific pointers for each chunks of data, for frames of data and audio. I will not talk too much about this because it's just mostly trivia at this point. You really won't need it when you are doing your stuff. But just to show you that this is the kind of information that you have in that metadata. So the important thing here is to remember that all of this is needed to even start streaming the video and start playing it. Tip number 2 is that you should always think of optimizing for streaming. FFmpeg has some arguments that make the video better at streaming. The two most important are these two. They make when you're doing the processing of the video, it usually goes in one pass. You know, it processes the video and audio, and then at the very end of the file, it drops the metadata because it has all the information about the video that it created. And those flags actually make the FFmpeg go and do a second pass and move all the metadata to the beginning of the file, which is necessary for the streaming, because this way you don't need the entire file to start playing. I believe that at some point the players started trying to be a bit smarter about it. So they are actually trying to seek for the metadata at the end of the file, so they don't really have to download the entire thing. But it takes more time, it makes the video slower to start. And also if you download partial video, you still won't be able to play it. So this is pretty important. You should always check the documentation and wiki from FFmpeg about it. Tip number 3 is bring your own arguments. We use Streamio FFmpeg, and it has like, it's all custom DSL for transcoding and everything, and I think you even saw some of that on one of the slides yesterday. But we quickly learned that it's better to just ignore this DSL and just pass our own custom arguments, because they gave us better control and we had a better idea of what's actually happening, and it was easier to optimize everything. So you may ask, why even bother with this library? The answer is pretty simple, because it has a pretty nice progress tracking. So you don't really need to write your own code to analyze the FFmpeg output and figure out at how much exactly is still processing and at which percentage of the file it is right now. Tip number 4 is there are no universal solutions, because one of the interesting things we've learned is that you can actually transcode the videos either by downloading the file on the server, then running the FFmpeg and then uploading it again, or you can actually give the FFmpeg the URL of the file, and it's going to transcode it on the fly, just download as much as it needs. And the second thing sounds great, right? It's going to be faster, obviously, but it actually heavily depends on the input video. We've learned that some of the videos, some of the inputs, some of the codecs are actually very, very bad at this. And the difference in speed between just downloading and then processing and downloading from fly was like 50 times. 50, not 15. So we get a lot of nasty calls from clients saying my video is still processing since yesterday. And we figure out that's the reason. So we had to fix that, actually. We never really found out which combination of codecs and data worked with which one, because it would require just a lot more data processing to figure this out. And also, when you download the video and then process it, it's actually a bit better in terms of you don't have to worry about the network interruptions during the processing. If there is a network interruption during the downloading, then you can always resume, right? But the transcoding, you cannot really resume from some place that it crashed on. You need to always do it from the start. And trust me, there are network issues on AWS and on S3, and we did have this problem. Tip number 5 is to use the presets. Obviously, you're not going to be an expert in everything, so you can offload some of the hard work to the smarter people. FFmpeg comes with presets for most common configuration options. They're like from ultra fast to ultra slow, and the ultra fast transcodes the video fastest, but the resulting size is going to be much bigger, and I think also the quality may be a bit worse. So you should use the fast presets for those low resolutions videos that I mentioned before, because you want to push the video as soon as possible to the user. I also learned that there is a technique that we didn't know back then. I only learned of it like a week ago when I was doing extra research for this talk. I've learned that some people are actually splitting the input file into smaller chunks, and they are transcoding them in parallel, which makes everything even faster. I would probably love to try this approach, but like I don't work on this project anymore, so it's kind of hard. Tip number 6, use profiles. H.264 has profiles, which are like sets of codec features. But not every device will support all of them, so you should always go with the highest one you can afford. It's gonna make the video smaller, it's gonna make it look better, but it's not gonna work on every device. This is the table from the FFmpeg wiki. It shows the iOS compatibility for various baselines. Unfortunately, I don't have this kind of table for other platforms, but we can already guess that if you want it to work everywhere, you should go for the baseline 3.0. Unfortunately, we are not all YouTube, so we cannot just use the different profiles and then serve them depending on the device. I really wish we could, but it would take a lot of time and it would be really costful. This is actually a super non-obvious issue, which is why it's my favorite one. You should always convert to WAV 420. There are different pixel formats in the video, different ways you can save the pixel information. And you should always go with this one because this is the one that all the browsers support. Some of them, if you give them a different kind of pixel format, they will play it, but some of them won't, and they will not tell you why. We had this problem, I believe, with Safari or Firefox. One of the clients was uploading a lot of videos made with a hand camera, and the initial video was a video from Apple QuickTime, and it uses the WAV for 2020, and it played nicely in Chrome. It plays nicely, I believe, in Firefox or Safari. I don't remember which one of those was. The other one, either Firefox or Safari, just didn't play it at all, the black screen. We had no idea what the hell was going on. It took us a while to figure it out, which brings me to my another point. Try to collect as much metadata as you can about the videos that you are processing. And it means that you should grab everything you can, both from the input video and from all the outputs that you are creating. Because we did that, we were able to check all the files that were reported that are broken on either Safari or Firefox. And then we kind of do the cross-analysis and we figure out, oh yeah, this is different. This is different than everything else we have in the system. This is how we actually managed to find it. Tip number 9, something kind of obvious. You should trust that the result from the FFmpeg is going to be correct and the file is going to work, but you should always verify it because the file can be cut during the transcoding and still technically claim that it's valid, even though it's incomplete. But you should be careful. Trust but verify sometimes manually because FFmpeg and FFprop can sometimes lie to you. It turns out that in some formats, you can have the information about the duration can be missing. And FFmpeg and FFprop, to be more precise, tries to do its best job to give you that information, so it guesses. It does an approximation based on the bitrate of the video and the size of the video. But unfortunately, it can be off for up to several seconds, depending on the size of the video. So when we kind of figure out the first problem with the video sometimes cutting, we implemented a validation that checked that the output file is the same duration as the input file, and you can guess that it started giving us a lot of false positives because of that. I'm not sure if it was a problem with MP4s, but I'm pretty sure that it was a problem with MP3s. And that's it. Thank you.
It was a very nice presentation, thanks. A lot of details. I would like to ask, how do you protect against vulnerabilities in FFmpeg, FFprop, etc.?
Well, when we did the proof of concept version, we didn't really care about that much because all the videos were coming from the customers of our client. If I were to do it right now, I would probably just isolate the whole thing and will not give it access to anything else. But we didn't really think of that much when we were building this. Like I mentioned, it was a few years back, so we weren't really that good at the time.
Thanks.
It wasn't, and also it wasn't really obvious that FFmpeg has vulnerabilities that can crash your server back then. It started popping up later. No more questions?
Okay,
Guess
thank
not.
you, Michal.
Thanks.